What's up? What's up? It's your man Jimmy Chan. All right, today we're talking about distribution of the sample mean. So basically what we're doing is we're taking a small sample from a large sample, right? A small sample size of n. And what happens with that is that what you'll realize is that the mean of that little tiny sample is going to be the same as the mean of the population. However, the standard deviation is going to change a little bit. It's going to be the standard deviation of the population divided by the square root of n. This is also called the standard error of the mean. So let's take a look at how we would work on a problem. So it says that the IQ, X, of humans is approximately normal. Okay, approximately normal. That's good to know. With a mean of 100 and a standard deviation of 15. Compute the probability that a simple random sample size of n equals 10 results in a sample mean greater than 110. This is compute P of X bar, meaning well, in this case, the sample mean is greater than 110, okay? So what I know is that the mean of this sample mean is going to equal to the mean of the population. So in this case, this is going to equal to 100. However, the standard deviation of this sample mean is going to be the standard deviation of the population divided by the square root of n. So in this case, it's going to be 15 divided by the square root of 10. All right? So, and that's going to be approximately 4.74. All right? So, a couple of things we would do. So, what we could do is we could find the z-score because it's approximately normal, right? And assume that what we're doing is that we're normalizing this so that the mean is 0 and the standard deviation is 1. So in order to do that, however, we'll have to find the z-score for that 110, right? For that 110. So in that case, that's going to be the X bar minus, or the X, I should say, minus mu of my X bar divided by the standard deviation of my X bar. Okay? So if that's the case, so this is how we would traditionally do it by hand. So what we have here is the 110 minus the 100 over 15 divided by the square root of 10. Okay? And what we're going to get, if I did it correctly, let me see here. Throw that in my calculator. I got a fraction here. The top is going to be 110 minus 100. The denominator is also going to be a fraction. The top is 15 divided by the square root of 10. And I get approximately, let me move this again, approximately 2.108. So it's going to be somewhere around right here. Not that far, but like right here, okay? And since it wants to be greater than, so we're looking for P of the X, well, in this case, our Z to be greater than 2.108. So we're really looking for this area right here. Okay? So that's what we're looking for, is that percentage. Now, that's how we would go about doing it. So you guys, with your TI-84, okay, so if we find z-score, then on the TI, not the IT, but the TI, we would do normal CDF of, remember this is the lower bound, comma, the upper bound, comma, the mean, comma, the standard deviation, okay? Now in this case, what we would do is the lower bound is going to be the 2.108, comma, the upper bound, which is going towards infinity, so we're going to call that 9,999, positive infinity, comma, the mean, in this case, since we found z-score, right, we're going to use 0, comma, 1. All right? On the Desmos, what you would do is going to be the normal distribution, and in that case you're going to put 0, comma, 1 for the mean and standard deviation, and then you're going to check the CDF, and for the minimum you'll put that 2.108, and for your maximum you'll leave the infinity. And either way, what you will get you'll get the P of z greater than 2.108 is going to be, let's see here, normal distribution of 0, comma, 1, 2.108. You're going to get approximately 0.175. Okay? So, and that would be my answer right there. So that will be the so-called by hand, the long way, right? Usually we would do a Z table for all of this type of stuff. But, so, again, we would still do, oh, I forgot to put the 2.108 here because that's a Z-score. So, essentially, this would be so-called by hand because then we had to find a Z-score and all that type of stuff. However, if you decide not to do a Z-score, so let's say on the exam and you're just going directly to the probability of it being greater than 110, you could also, so instead if we find Z-score, I'm going to say if we use mu of x bar and sigma x bar, okay, no Z-score. In other words, letting our calculators do the work for us. On the TI, we would do the normal CDF, same thing, right? Lower bound, which would be in this case 110, right? Comma 9,999 for infinity, comma, our mean in this case is going to be our regular mean, which was 100, right? So this was the mu of x bar, comma, the standard deviation of x bar, which was 15 divided by the square root of 10. And my suggestion is that you would actually plug it in that way just so that I don't have to worry about decimals, right? I don't have to worry about decimals at all, right? I'm actually using the actual, all those decimal places that is given to me, all right? So that should give you the same thing. And on decimals, we would still use the normal dist or normal distribution of, now in this case, the mean would be 100 because that was my mu of x bar, comma, my standard deviation, which I would type in as 15 divided by square root of 10, which is my sigma of x bar. And in that case, check off the CDF. My minimum is going to be 110, and my maximum leave as the infinity. And this will also give me, actually, let's undo that. Let's move this more to the right here. Or the other left. This will still give me the P of that x bar being greater than 110 is going to be approximately 0.0175 as well. Okay, so either way you do it, you're going to get the same exact probability. All right, so again, longhand, find the z-score and then go from there. Shorthand, skip the z-score, just use the mean and standard deviation that you found and you'll get the same thing, okay? So on your own, you might want to just try and practice on some of the different scenarios here, okay? So let's say we have a simple random sample. Wow, this is awful. I know I can write better than that. Let's say we have a simple random sample where our mean is equal to 86 and our standard deviation is equal to 24, okay? And we have an n equal to 64. There we go. All right, so let's say we have this situation here. And what I want you to find in part A is the probability of x bar being greater than 90.2. So same idea as above, greater than. Part B, probability that x bar is less than or equal to 78.65. And C, the probability of the x bar being between 83.9 and 92.75, okay? So try that out and see what you guys get. You ought to get the probability that's greater than 90.2 should be about 0.0808. For less than 78.65, you should get 0.0071. And for between 83.9 and 92.75, you should get 0.7458. Now remember, these are probabilities, right? And the probability has to be between 0 and 1. So if you get something larger than 1, something's wrong, okay? Then you've probably found a z-score instead. And the thing of it is that if you want to check it out, what you guys can do is say, okay, let me put something like this down here, right? Let's take a look at, let's say part A here, right? So you can see that the mean is 86 and the standard deviation, so my mean of x bar is equal to still 86, but my standard deviation of x bar is now 24 divided by the square root of 64, which is about 3. So that means this is 89, this is 92, this is 95, this is 83, because I'm adding or subtracting 3, right? So 80 and 77. So if I want greater than 90.2, that means I'm looking at something like this. So I am actually looking for this area right here, right? And we talked about how this area right here is 13.5. This area right here is 2.35, and then right in here is like was it 0.015, right? So very, very small. So the 0.08 makes sense, right? So that is what you kind of have to look at, where the second one is less than 78.65. So 78.65 is probably something like this. So we're really looking for this little tiny area right here, okay? So for it to be way smaller, makes sense. And then for the third one, we're looking at 83.9. So it's really very close to this line right here, right? And 92.75, so just past that 92 here, right? So we're looking for all of this area right here, right? Just within one standard deviation is already 68%, right? And then we got this, so getting around 75% would make sense, right? So take a look at that and see if you guys get exactly the same thing or not, all right? So good luck, and hopefully you guys get some practice in, and I will talk to you later. See ya. Bye.